Okay, in this lesson, we're going to be graphing a specific rational function, and we call that the reciprocal function. So the reciprocal function takes the format of f of x equals 1 over x. So if we want to find out what that looks like, we've kind of already graphed this shape with our other rational functions that we've graphed. But if we want to see what it looks like, you could do a table of values. So we know we can't use x equals 0 because 1 divided by 0 would be undefined. So we know there's not a value there. So that also tells us that we have a vertical asymptote right here at x equals 0. If we put 1 in, 1 divided by 1 is 1. If I put 2 in, I get 1 divided by 2 is a half. So 1 to 1, 1 would be right here, 2, 1. So I can see that it looks like to me if I put 3 in, I'm going to get to 1/3. That I'm getting closer and closer to the x-axis. So I know I have a horizontal asymptote at y equals 0, and I know that from what we've learned with our other rational functions. The degree here in the original function is different. The degree in the numerator up here, this is a degree 0, and down here is a degree 1. They're different. The denominator is bigger than the numerator, so that means our horizontal asymptote is at y equals 0. So I can see from my table of values that those points are indeed approaching that. And so then on this side, it will follow that asymptote. And then we just need to figure out the other branch. Well, if you pick -1, -1 divided by -1 is -1. So we can tell that this branch comes over here, and it will do the same thing. And so here's our two branches. So the shape of this graph is called a hyperbola. That's a new word. And the symmetrical parts are called branches. I've been using that word all along, so we know branches. Okay, so we kind of talked about this already, that we have a vertical asymptote at x equals 0. There are no x-intercepts, and there are no y-intercepts. And the horizontal asymptote is y equals 0. So here we have this and this. And the interval of increase and decrease. So that's not anything that we're going to need to worry about on these particular functions. We can tell as we move here from the left, as I'm moving left, this part is decreasing. And then after the vertical asymptote, I pick up right here, and then it's decreasing again. So we've got increasing up here, but then it decreases. So as I move to the right, everything is decreasing, but we're not going to write the interval of increase and decrease. That's not anything that we're going to test you on, so we're not going to worry about that on this particular graph. So let me put these back. But domain and range, yes. So the domain is going to be all reals, and keeping track that x cannot be equal to 0. We have to take out the vertical asymptote. And then the range is once again all reals, but y cannot be equal to 0. We have to take out that horizontal asymptote. Okay, so if you want to compare this, these are functions that we have studied in the past. So this one right here we did in Math 2, the absolute value of x. When we had transformations that went with that, we had our a, h, and k. X squared was also Math 2. X to the third we did this year. Square root we did this year. And cube root we did this year. And once again, they all have the a, h, and k associated with them. So now the new one is the reciprocal function, 1 over x. This is our reciprocal function. And this one has an a, h, and a k with it. So a is still our vertical stretching and shrinking. And h is going to be our vertical asymptote. And then the K is going to turn out to be the horizontal asymptote. So this is just an example of the one on the left is your parent function, 1 over x, and then when you take a transformation and you move it h and k, this is moving h right here, and then this is moving k right here. So this just shows you how the asymptotes move. And then you can work from where you can kind of pretend that this new, where the two asymptotes cross, you can kind of think of that maybe as a new 0, 0 if you want, in reference to find some other things with the graph. So we'll go ahead and graph this one. So right now we know that this is my vertical asymptote at 2. So I'm taking my graph and I'm moving it right 2. So x equals 2. So I'm going to sketch my vertical asymptote. And then this one right here is our horizontal asymptote. So it's going to be at y equals 3. Now we're going to use this A right here. This is A to help us draw the branches in the right spot. Now since A is positive, my branches are going to be, if we were thinking of this point right here as 0, 0, and this is the first, second, third, fourth quadrant in relation to the asymptotes, then if A is positive, your branches are always going to be in the first and the third. So here and here. And if A is negative, then the branches go in the second and the fourth. So they would come over here and here, because the negative sign is our reflecting. So it would put it in this kind of what I would think of as second and fourth. Okay, so let's figure out what this A does of 1. So A of 1, if you start right here where your asymptotes intersect, if you go in a 1-to-1, 1 over 1 pattern, or a 1-to-1, I don't know how you want to write it, but it's a 1-1 pattern. So I start here and I go to the right 1, up 1. That point right there is on my branch. So I know my branch does this. So I could do this without having to go to a graphing calculator or typing in my equation in my calculator to get my information. So same thing, I could do 1, 1, so I'm going to go the other direction. I know it's symmetric, so I'm going to go negative 1, 1, so there's going to be a point right here. These branches are symmetric to each other, so that 1, 1 pattern works both positive and negative. So domain is going to be all reals, and x cannot equal, take out your vertical asymptote, and the range, our horizontal asymptote was at y equals 3. So that means the range is all reals, but y cannot equal 3. Okay, so once again, because we have just an x in the denominator, I know my vertical asymptote is x equals 0. There is no shifting, so there's up here, this k is a 0, so that means our horizontal asymptote is also 0. So here we go, vertical and horizontal asymptotes in here. And now we're going to use this A to figure out our branches. It's positive, so I'm going to go first and third. And I'm going to go in a 4, 1 combination. So what that means is from my center right here, I'm going to count 4. 1, 2, 3, 4 to the right, up 1, put a point. Or I'm going to go 1, 1, 2, 3, 4, and put a point. So I know my branch includes those 2 points, so my branch does something like that. And then I'm going to do the same thing down in the third quadrant. I know they're symmetric, so if I go left 1, down 4, or I go left 4, down 1, those points are going to be on my branch, so I can just go ahead and sketch that branch in. So domain is going to be all reals, and x cannot equal 0. Range is all reals, and y cannot equal 0. Okay, once again, I noticed this negative sign out in front, so we have a negative that we're going to have to keep track of. So that means I'm going to be talking about like the second and the fourth quadrants for my branches. So right here, when I say my vertical asymptote, it's going to be x equals -5, and my horizontal asymptote is going to be at y equals -2. So -5 vertical asymptote, -2 is my horizontal asymptote. It's negative, so I know my branches are going to be in the second and the fourth. This is a 1, A is 1, so I'm going to do a 1-1 combination from my center here where the two cross, my two asymptotes cross. So 1-1 would go right here. So my branch looks right here, and here's the other one in a 1-1 combination. And there's my other one. So my domain is all reals. X cannot equal -5. And the range is all reals, and y cannot equal -2. Okay, and now can we write the equation? So to write the equation, we need to look at this format here. So we have y equals a x minus h plus k. So we need to find our vertical and horizontal asymptotes. So vertical asymptote for this one will be right here, horizontal asymptote right here. So if we're looking at that, we're going to say y equals, and then my horizontal asymptote is located at -3, so I'm going to say x plus 3, or excuse me, my vertical asymptote. Horizontal asymptote is located at -8, so I'm going to say -8 on the end. So all we need to do is figure out A. So to find A, find a point, a grid point, the first grid point closest to where the asymptotes intersect right here. So that would be this point right here. So that looks like that is a 1-1 combination, like 1-1. So that means A is 1. So I would just put a 1 here. And my graph is in the first and the third quadrant, so to speak. So I know that it's a +1. Okay, over here, let's go ahead and put in here's our vertical asymptote. So that's at 0. So we don't really need to write -0 or +0. We'll just leave it as an x. So x in the denominator here. Whoops. And here is the horizontal asymptote. So that's up 3. So +3. And then right here's where they intersect. So I need to find my A. So I'm going to try to find the grid point where the graph crosses closest to where my asymptotes intersect. So these 2 points right here. And then over here we have these 2 points. So let's kind of count it out and see what kind of number combination we're talking about. So from the center, I'm going over 5, 1, 2, 3, 4, 5, up 1. Same thing here, it's 1, 5. So A is going to be 5. But because my branches are in what I refer to as like the second and the fourth quadrant, we know it's negative. And that's our equation. So that's just a special rational function we call the reciprocal function, where we just have the two branches diagonal from each other. They're symmetric. So they'll always either be in the second and the fourth or the first and the third.